So here, as we started with atoms and molecules, in part 1 we covered with what are atoms, what are molecules, and laws related to chemical combination. So as I told, law of chemical combination, where it was given by Lavoisier and Joseph L. Proust. So there are two laws of chemical combination. The first one, here the two laws of chemical combination. The first one, mass can neither be created nor it be destroyed. Always it remains constant only. So law of conservation of mass. What the law states? Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. If you remember, we started with this law, and then later on we discussed about law of constant proportion. We took different sources, like water was collected from different sources, pond, river, ocean, sea, and ultimately we got that whatever the source it may be, always the composition is constant. So here the law of conservation states, in a chemical substance the elements are always present in definite proportion by mass. If you remember, I discussed with the example of water. We took different sources. We took water from different sources. Whatever the source it may have, water is the combination of hydrogen and oxygen. Two atoms of hydrogen combined with one oxygen. So here by mass, if we calculate the molar mass of hydrogen is 1. So 2 multiplied by 1, whereas oxygen is 16. So mass of water is 18 altogether. We represent it with U. And if we calculate ratio, 1:8 atoms of hydrogen and oxygen are getting combined in the formation of water. So this is what we did in our previous class. So after, they can ask about the different combinations. Even the ammonia's example is also given in your textbook. Ammonia is the combination of nitrogen and hydrogen. Here the molar mass of nitrogen is 14, which get combined with 3 atoms of hydrogen. Molar mass of hydrogen is 1. So thus the ratio is 14:3. Or if they will ask for the total molar mass of ammonia, it will be 14 plus 3, 17 U. So in this way we can calculate molar mass. And after that we started with the Dalton's atomic theory. So let's have the recall of it. Dalton's atomic theory states that all matter is made up of very tiny particles called atoms, which participate in chemical reaction. So here every atom is made up of tiny particle, and atoms are indivisible particle which cannot be created or destroyed in a chemical reaction. So as per Dalton, atom was the tiniest particle. If you remember, we discussed still the atomic theory was there. The scientists were unaware of electrons, protons and neutrons, the subatomic particles. So they were only thinking that atom is the smallest particle. Later on, they found that these subatomic particles are there. But for your examination point of view, this atomic theory is very important, which you need to memorize in points. The first one, all matter is made up of tiny particle called atoms. And then the atoms are indivisible particle which cannot be created nor be destroyed. Atom of a given element are identical in mass and chemical properties. So here, if it is identical element, like if we take many atoms of hydrogen together. So here, if there are 10 hydrogen atoms, whatever the number it may be, always they will be identical by mass. Their mass will be constant, their chemical properties will be constant. And the same way, if we take different atoms, like one is hydrogen, other is oxygen, other is potassium or sodium, all are different atoms. So their masses will be different, their properties will be different. So we can say that atoms of the different elements have different properties, whereas the atoms of the same element have the same identical properties. Now here, Atoms combine in the ratio of small whole numbers to form compounds. Atom always combine in small whole numbers. Once again, if we talk about the ratio, here ratio of hydrogen and oxygen is 2:1. So it's a whole number. In the same way, for the case of ammonia, it's 1:3. If we take the case of carbon dioxide, it's 1:2. Always they combine in whole numbers. They never combine in fractions. So this is what we covered with Dalton's atomic theory. And then the relative number and kind of atoms are constant in a given compound. If we come across any compound like carbon dioxide, always the elements are constant, like it is the combination of carbon and oxygen only. So here they always get combined in constant ratio. Now we covered even the in-text questions. Those who are fresher who joined today only, they can go through with this part 1 which we did previous day. So today we are focusing on the part 2, which is starting from the atom. So we are going to have the class for the detailed explanation of atom. What is an atom? Let's start out. Have you ever observed a mason building wall? From these walls, a room and then a collection of rooms to form buildings. So here, when we say that what the building is made up of or a wall is made up of, so everyone will answer like unit of wall is brick, as every wall is made up of brick. And the same way, if you remember the cell chapter of biopart, you came across with the cell. Building block of body is cell. In the same way, every compound, or we can say that every matter is made up of atom. So what is atom? The final explanation is the building block of all the matter is atom. It is the building block of matter. As the building block of body is cell, in the same way building block of matter is atom. How big are atoms? Now atoms are very small. So atoms are very small. They are smaller than anything that we can imagine or compare with. More than millions of atoms when stacked would have a layer of barely a thick as sheet of paper. So yeah, atoms are very small. They're smaller even we cannot imagine like how small they are. If we combine millions of atoms, they will be as thicker as sheet of paper. So this point you need to remember. The radius of atom is measured in nanometer, as they are very smaller. So we need to use smaller units. Atom are measured in nanometer. What is 1 nanometer? The relation is 1 nanometer is nothing but 1 upon 10 raised to 9 meter. So we can say that 1 meter is equal to 10 raised to 9 nanometer. So if we divide 1 meter with 10 raised to 9, we are going to get the unit which is equal to nanometer. Now you can imagine like how small atom is. Here the different examples are given. Those are interested, they can remember it. But for exam point of view, these are not very important. They never ask you to give the atomic radii of hydrogen, water or molecule of hemoglobin. Like that they never ask. Only you need to explain like what is atom or how the atom radius is measured. We might think that if atoms are so insignificant in size, why this word insignificant is used? Because they are very small. We cannot see them. Why should we care about them? Then why we are reading in detail about atom? Why they are so important when they are very small in size? This is because our entire world is made up of atom. So why we give importance to atom? Because everything is made up of atoms only. We may not be able to see them, but they are there and constantly affecting whatever we do. So here atoms are there and they are constantly affecting in our functions. Through though modern techniques, we can now produce magnified image of surface of elements showing atoms. So here, as now we are having advancement in technology, we can see like how the atoms are looking out, how the surface is seen with the combination of atoms. We can find out that So this is an image of the surface of silicon. If silicon is seen under electron microscope, it looks like this figure. Now, what are the modern day symbols of atoms of different elements? So here, when Dalton proposed atomic theory, there was no proper explanation. So as per Dalton, Dalton was the first scientist to use a symbol for different elements in a specific sense. So he designed, as no proper way of representation was there, so he made some designs and he symbolized the atom. So this can be again a 1-mark question. So this also you need to memorize. Hydrogen, it looks like a sphere with a dot in the center, and the same way carbon, it's completely dark sphere. Oxygen, it's a completely open out, and the same way here all the symbols are there. Once all of you go through with this to learn the symbols. So this part is not very important, but still for your idea you can remember all the symbols which can be asked in 1-mark question MCQ part. Now let's continue with the next part. Here we covered with atom. So the next topic is molecule. So all of you already know that molecules are made up of atoms. So when atoms combine, they forms molecule. In the beginning, the names of elements were derived from the name of the place where they were found for the first time. So how they were giving the name? They started giving the name from where they were found. For example, the name of the copper. So how the copper got its name? Because it was taken from the Capras. Some names were taken from the specific color. Like gold was taken from the English word meaning yellow. So as the gold looks yellow in color, so the name was given. And then from the English word, nowadays, IUPAC, that is International Union of Pure and Applied Chemistry. So this is the advanced one. They can ask you for the full form. What is the full form of IUPAC? So it's International Union of Pure and Applied Chemistry. As per that, the naming is given. Is an international scientific organization which approves names of elements, symbols and units. So this is the main unit of the chemistry which is symbolizing all the elements. Their symbols are given, their units are given, their masses are given. Many of the symbols are the first one or the 2 letters of the element's name. So when they started with naming the element, how they started? They first wrote the complete spelling. So for if you see hydrogen, hydrogen is starting out with H. So its symbol they used H. And the same way for aluminium, they took the first 2 letters, A and L. Always the first letter must be capital and second letter must be smaller. If we write capital A, capital L, it is considered wrong. This is the wrong presentation. We should not write the symbol of the element with 2 capital letters. Now one more important question is there. What is the difference between C capital O and C small o? When we represent first letter capital and second letter smaller, it represents a symbol of an element. But in the same, if we represent both are like capital, it's a compound. So how we are going to read C small o? C small o is cobalt, whereas both capital C, capital O, it is representing carbon monoxide. So C for the carbon, and if one oxygen is there, we call it as mono. For oxygen, oxide word is used. So this is the compound of carbon monoxide. Now what are compounds? Compounds when elements combined chemically, and if the substance is not having the individual property. When we see carbon monoxide, we are having the separate property rather than carbon and oxygen. If the property of the substance is entirely different from the substances of which it is made, we call it as compound. Now, I hope like everyone understood what is the difference between CO and C small o. While writing the symbols, always we should remember, like when we represent any element which is made up of 2 letters, like if the symbol is given by using 2 letters, always the first letter must be capital, second letter must be smaller. So this is representing cobalt symbol. If both are capital letters. The combination is representing compound. So it is the compound of carbon monoxide. Now CO represents cobalt, not C capital O. Symbols of some elements are formed from the first letter of the name and letter appearing later in the name. So here sometimes two letters are used, sometimes the first letter only. For example, chlorine, though the first and second letter is CH, but we used C and L. In the same way for zinc, Z and N is used. That is the first letter and third letter. Other symbols have been taken from the name of element in Latin. So here some are taken the Latin words, German or Greek. For example, the symbol of iron is Fe. Iron, it is starting from IR, but in symbol we are going to use Fe from its Latin name, which is ferrum. Latin name of iron is ferrum. From ferrum we are going to use Fe. Sodium is Na, that is natrium. You need to remember all these names. What are the Latin names of the elements? Sodium's Latin name is natrium. Potassium is K from kalium. Therefore, each element has a name and a unique chemical symbol. Every element is having its unit and its unique symbols are there. So we need to memorize all the symbols. This table is also very important. Everyone must learn it very nicely. This is the first step. If you know the symbols of the element, then only the compounds can be learned easily. Aluminium, Al, argon, Ar, barium, Ba, boron, B, bromine, Br, calcium, Ca, carbon, C, chlorine, Cl, cobalt, C small o, copper, Cu, fluorine, F, gold, Au, hydrogen, H, iodine, I, iron, Fe, lead, Pb, magnesium, Mg, neon, Ne, nitrogen, N, oxygen, O, potassium, K, silicon, Si, silver, Ag, sodium, Na, sulfur, S, uranium, U, zinc, Zn. So these are the important symbols which you come across. So you need to learn it properly, and this we will use in crisscross model, which is the next part of the chapter. The above table is given for you to refer to whether you study about elements. Do not bother to memorize all in one go. That is, in simple one step, you cannot remember. So these all symbols, they need constant revision. You need to revise it every day, like you need to repeat it every day, twice or thrice. By constant repetition for few days, you are going to learn all the symbols. Now here, atomic mass. This is the next topic, which is again important one. What is atomic mass? The most remarkable concept that Dalton's atomic theory proposed was that of the atomic mass. According to him, each element had a characteristic atomic mass. Now here, as per the Dalton's atomic theory, if you remember, he said that every element has constant atomic mass. So atomic mass of every element is fixed. Each element had characteristic atomic mass. The theory could explain the law of constant proportion. What do you mean by constant proportion? If you recall back, every element is made up of fixed combination. We took the example of water. Whatever the source or irrespective of source, it is made up of hydrogen and oxygen only. That is in the constant ratio, 2 hydrogen with 1 oxygen. Now, law of constant proportion so well that scientists were prompted to measure the atomic mass of an atom. So when they got this law of constant proportion, then they started thinking about how the atomic mass of an element can be obtained. Since determining the mass of an individual atom was a relatively difficult task, relative atomic mass were determined. So here, if they want to find out the atomic mass of any particular element, it was very difficult. So thus they started calculating the relative mass. For that, they took one constant atom. Like first they calculated what is the atomic mass of isotope of C12. C12 is carbon, and then isotope. In this chapter we are going to learn about some other new topics. Isotope, it is a sometimes the elements will have same atomic number but different atomic mass. Like atomic number is number of electrons or protons present in any atom. So what are isotopes? Prior to learning to this atomic number, we must know about the topic what are isotopes. So isotopes are elements which have same atomic number but different atomic mass. If we take the example of hydrogen, hydrogen has got 3 isotopes. We represent it by 1 as a subscript and 2 as a superscript. And the same way 1, so here 1, 1, 1, 2, 1 and 3. That is, number of proton and electrons are same in all the type of hydrogen. For the first isotope, there is no neutron. Again, if you recall back the subatomic particles, there are electrons, protons and neutrons. Electrons are represented by negative charge, protons with positive charge, neutrons are chargeless one. In case of hydrogen, which is known as protium, there is no neutron. Only it contains 1 electron and 1 proton. Now what is atomic number? Atomic number is number of electrons or protons present in any atom. So here there is 1 proton and 1 electron. If we subtract, this upper superscript represents atomic mass. Atomic mass is combination of protons and neutrons. These are all very important questions of this chapter, where they ask what is atomic mass, what is atomic number, what are called nucleons. Nucleons are the subatomic particles which are present inside the nucleus. If you see the structure of nucleus of an atom, its nucleus contains protons and neutrons. So as protons and neutrons are present inside the nucleus, we call it as nucleon. Atomic mass is the sum total of protons and neutrons. Atomic number is number of either electrons or protons. So here in case of hydrogen, as I told, there are 3 isotopes. One is called protium, other is called deuterium and third one is called tritium. In all the isotopes, number of protons and electrons are same, whereas there are different number of neutrons. For the first case, 1 minus 1, 0 neutron is there. For second case, 2 minus 1, 1 neutron is there. For third case, 3 minus 1, 2 neutrons are there. As all the 3 contains same number of protons and electrons, their chemical properties are same. That's why we have same chemical properties for hydrogen. By hearing to this concept, you may get confused that if the number of protons are different, there are 3 different kinds of hydrogen, then how they are behaving same, how their chemical properties are same. So this explanation was given by Mendeleev when he prepared his periodic table. Mendeleev's periodic table is based on isotopes. Like though the time of the periodic table, isotopes were not discovered, but he used this criteria to have the periodic table. He concentrated that how many protons and electrons are there in any atom. As electrons only participate in chemical reaction, they only can be gained or lost. So depending on that, the chemical properties were decided. As the number of electrons are same in case of isotopes, their chemical properties will be same. So this is the topic related to isotope. Now, as the elements are having same number of electrons, so their chemical properties are same. When we came across the atomic mass, if you remember, I told you like atomic mass, there was no proper way to find out, like no instruments were there to measure the mass of an atom. So they first calculated the relative atomic mass of one atom, and from there they started to find out rest. So let's take the example of the compound carbon monoxide. Carbon monoxide, how it is formed? By formula you can say like it is the combination of carbon and oxygen. Carbon monoxide is formed by carbon and oxygen. It was observed experimentally that 3 gram of carbon combines with 4 gram of oxygen. Now here, if suppose 3 gram of carbon will combine with 4 gram of oxygen, then there will be the total combination of 3 plus 4, 7 grams of carbon. So here, in other words, carbon combined with 4 by 3 times of mass of oxygen. Now when they calculated how many carbons, like if 3 combines with 1, suppose we take like unitary method, 3 carbon, 3 gram combines with 4 gram of oxygen. What about 1 gram? It will combine with 4 by 3 gram of oxygen. So like that, the relative mass they started to calculate. And suppose we define the atomic mass unit abbreviated as AMU. So here AMU, whenever we find any atomic mass, any atom's atomic mass, we need to give the unit which is represented by AMU, or simply we can write only U letter, that is unified mass. Here this representation was given by IUPAC recommendation, and it is equal to the mass of one carbon atom. So as to find out the relative mass, to find out the atomic mass, they needed any relative element. For that they took the isotope of carbon. As I told, isotope which have the same atomic number but different atomic masses. There are two isotopes of carbon. One is C12 and other is C14. One is having atomic number 12, other is having atomic number mass number 14. That is, number of neutrons are different. If you want to represent this isotope, how you are going to represent it? Both are carbon, their atomic numbers are written in the subscript and mass numbers are written as a superscript. So here their mass numbers are different. Atomic number is same, mass number is 14 for the first one and 12 for the one is having 12 and other is having 14. So number of neutrons are different in both the cases. So here we need to add out both. So here this they took the constant like C12, where they started to find out the atomic masses of the other element. Now they started with the atomic mass. So final definition of atomic mass is given as one atomic mass unit of is a unit equal to exactly 1/12 of the mass of one atom of carbon 12. So this is the final definition which you are going to write. So as we took the different examples, so final definition is one atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon 12. The relative atomic masses of all elements have been found with respect to the atom of carbon 12. So with respect to this carbon 12, that is isotope of carbon, they started calculating rest of the masses. Now imagine a fruit seller selling a fruits. So here suppose a fruit seller is selling some fruits. He will be having a beam balance. With the help of beam balance, he will be keeping some weight on one of the pan and other whatever the vegetables or fruits he want to sell, that he will keep in the other pan. But as atoms are very small units, we need some specific measurement units. So for that they took this carbon 12 isotope. Out of this whole page you need to memorize only atomic mass definition. Now the next topic is how the molar masses are calculated, or atomic mass which is given by the unit U. For this you need to remember this table where the elements names are given, their atomic masses are given. Hydrogen, its atomic mass is 1, carbon 12, nitrogen it's 14, oxygen 16, then sodium 23, magnesium it's 24, sulfur 32, chlorine 35.5, calcium 40. Now this table how you are going to use? So let's learn about that. If you want to find out the atomic mass of sodium chloride, So from this table, how we are going to calculate? Sodium's atomic mass is given 23. Chlorine is given 35.5. So first we will apply the sodium's atomic mass 23 and then chlorine is 35.5. Then add them together. Thus it is 58.5 unit. So this is also one of the important question of this chapter. They are going to give some examples of the compound where you need to calculate molar mass. Only few examples are there, few elements are there which are in your syllabus. If you remember their atomic masses, easily you can solve this question. These type of questions are of 1 mark questions. Easily you can get 4 to 5 marks from this. Out of this chapter, very selected questions are there. As I told, who gave the law of chemical combination? That is one of the important question. Dalton's atomic theory is the next most important question. Then what is atomic mass? Then how to calculate atomic mass of the compound. So let's try for one more example. If some examples are there which are not in the table, they will provide their atomic masses in the examination. Whenever the question will be given, aside atomic masses of the particular element will be given. By using them, you can calculate the masses easily. Now, if you want to find out the mass of Na2O, it's representing sodium oxide. How to calculate? Whatever the subscript will be there, write down that number first and the molar mass of the element. Here sodium is there. Molar mass of sodium is 23 plus oxygen is 16. Now multiply them. So it's 46 plus 16. Then adding together, thus it is 62. After completing calculation, put the unit. Either you can represent only simple u or the complete AMU. All small letters can be written. It's very important. Otherwise, you are going to lose half marks for this. So now this next topic is also over. The first question is define atomic mass unit. Already we completed one atomic mass. Then why it is not possible to see an atom with the naked eyes? Why we cannot see atom? As because it is very small in size, even smaller than our imagination. As atom is very small, whose radius is equal to 1/10 of the meter, so thus we cannot see it with our naked eyes. Now what is molecule? Molecule, when atoms combine together, they forms molecule. Molecule has free existence, but atom cannot exist freely. If you remember, I told you like molecules can exist freely. Molecule of carbon dioxide is CO2. It can have independent existence, but atom cannot exist independently. A molecule is in general a group of 2 or more atoms that are chemically bonded together, that is tightly held together by attractive forces. Now here, when atoms tightly held together, when they combine hardly, they forms molecule. Molecule can be defined as the smallest particle of an element or a compound. So this is the definition. What is molecule? It is the smallest particle of element or compound. Whereas the difference between atom and molecule, that can be one more question. Atom is the smallest particle of element and molecule is the smallest particle of compound. And atom cannot exist independently, but molecule can exist independently. And for the third point, you can use the symbols to represent their difference. All the properties of the substance, atom of the same element or of the different elements, can join together to form molecules. So here, either the atom of the same, like if suppose 2 oxygen atoms get combined, they forms oxygen molecule. And the same way, if the atom of different elements combine, for example, if carbon and oxygen is combining, depending on its combination, if 2 atoms get combined, it will form carbon dioxide. If only 1 atom is there, it will form carbon monoxide. So this is how the compounds are formed. Compounds are formed either by combination of same identical elements or the different atoms combined together to form compounds. Now let's further continue with This chapter is very easy where only few concepts are there. If you learn those concepts easily, you can cover out the chapter within half an hour. Now the molecule of element. Already we did about the molecule. There are different types of molecules. It can be either monoatomic, diatomic, triatomic. Sometimes they will ask for the definition, or they will give the atom example, and they will give the example of the molecule, and they will ask like whether it is monoatomic, diatomic or triatomic. If suppose helium is there, He represents helium, only single atom is there, so it is monoatomic. Mono means only single atom is there. If we take example of oxygen, there are two atoms, so we call it as diatomic. If three atoms are there, like Al3, we call it as triatomic. If four are there, like P4, we call it as tetraatomic. If more than 4, like S8, 8 atoms are getting combined here, so it is polyatomic. Now what are these, how we are counting out this monoatomic, diatomic, triatomic, tetraatomic or polyatomic? Depending on the number of atoms present in the molecule. So here in helium only one is there, so we called it as monoatomic. For case of oxygen, O2 is there, 2 atoms are there, so it is diatomic. For aluminium, 3 atoms are there, so it is triatomic. And then for phosphorus, 4 atoms are there, so it is tetraatomic. For sulfur, 8 atoms are there, thus it is polyatomic. If more than 4 are there, we call it as polyatomic. They can ask for any example. Now let's learn about definitions. So here the molecule of an element are constituted by some type of atoms. Molecule of many elements such as argon, helium, etc. are getting argon, helium, etc. are made up of only one atom of that element. But this is not the case with most of the non-metals. For example, molecule of oxygen, it is consist of 2 atoms of oxygen. Hence it is known as diatomic. If the molecule is made up of 2 atoms, we call it as diatomic. If 3 atoms are there of oxygen unit, now here there are 3 atoms in the oxygen. If suppose 3 atoms of oxygen are getting combined, we call it as triatomic. Triatomic oxygen is called ozone. This is the formula for ozone. If single is there, we call it as nascent oxygen. You need to remember all these names. Nascent oxygen is the oxygen which is in very active form. And the next one, after nascent oxygen, ozone, if 3 atoms of oxygen is there, and then if only 2 are there, we call it as oxygen. Now after, the metals and some other elements such as carbon do not have a single structure but consist of very large and indefinite number of atoms bonded together. Let's look at the atomicity of some non-metals. Atomicity, what is atomicity? The number of atoms present in any compound is called atomicity. Now already we discussed argon, it is monoatomic as only one atom is there. Helium, only one is there, so it is also monoatomic. For the case of oxygen, we write the symbol as O2. 2 oxygen atoms are there, so it is diatomic. Then for the case of nitrogen, it's N2, again it is diatomic. For the case of hydrogen, it is H2, again it is diatomic. Chlorine, Cl2 is there, again it is diatomic. Phosphorus, P4, so it's a tetraatomic, 4 are there. Sulfur, it is S8, thus it is polyatomic. What is atomicity? Atomicity is number of atoms present in any molecule. Depending on the number of atoms, we give its atomicity. If 1 is there, monoatomic. For 2, diatomic. For 3, triatomic. For 4, tetra. If more than 4 are there, we call it as polyatomic. Now, molecules of compound. Atom of different elements join together in different proportion to form molecules of compound. For example, here suppose if we take the example of water, already we discussed in the law of definite proportion. Water is made up of hydrogen and oxygen in the ratio 1:8. If you recall it back, how we did it? Molar mass of hydrogen was 1. It got combined with 2 atoms. So 1 multiplied by 2, and then oxygen, its molar mass is 16. If we take the ratio, it's 1:8. Now the another example is given, ammonia. Ammonia, it's NH3, where 14 unit molar mass of nitrogen is 14. For hydrogen, it is 3 multiplied by 1. Thus the ratio is 14:3. The next one is carbon dioxide, CO2. Molar mass of carbon is 14. Oxygen, 2 multiplied by 16. Thus it is 14:32. If we cancel it, 2 sevens are 14, 2 16 are 32. So thus it is 7 ratio, carbon dioxide is given. Okay. So it's a 32. Then the ratio is 3:8. Carbon, it is 14. And for oxygen, it is 32. So I'll check it once. Now let's continue further. What is an ion? This is also one of the important topic. Compounds composed of metals and non-metals contains charged species. So here generally compounds are made up of metal and non-metal. So here that too they are charged species. If we see metals mostly they are positive charged one, as they are the electron donors. They have more number of electrons. So to get the octet configuration, if you remember, we discussed about electronic configuration. Sodium's electronic configuration is 281. For that, already in my previous class I told like you need to learn out the atomic numbers up to 20. If you remember them, by using that atomic numbers, you can find out the configuration. Sodium's atomic number is 11. So in the first shell it will have 2 electrons, it's constant. In second shell they can have up to 8 electrons. So here it got 8 electrons in the second cell. Now 2 plus 8 is 10. Here out of 11, 1 is remaining, that will be in the third shell. Now it has got 1 electron extra. Every atom, as per the law of octave, it want to complete its outermost shell with 8 electrons. So for that purpose, it will donate 1 electron. If it is donating this 1 electron, it will get 2 and 8 combination. So as it has given 1 electron, 1 negative charge is less here. So sodium will get positive charge. And the same way, if we take the example of chlorine, its atomic number is 17. So its combination is 2, 8 and 7. Always in the first shell there are 2 electrons. For the second cell there are 8 electrons. And for the third one remaining, that is 2 plus 8 and remaining 7 in the third shell. Now to complete its octet, it need to add up with 1 electron. So chlorine will get 1 electron. As it is getting 1 negative charge extra, so it will have minus charge. These are the charged species. When there is charge development on the atom, we call them ion. When they have opposite charge, as already all of you know, opposite charge species attract each other. So they attract and they get combined and they form compound. So in this way, sodium chloride is formed. So now again let's continue with what are these positive and negative charge groups. The charged species are known as ion. This is the definition of ion. What is ion? The charged species are known as ions ion may consist of single charged atom or a group of atoms or and that have net charge on them. So here ion, they may have the single charge or they may have group of charge. A negative charged ion is called anion. This is also very important. If there is negative charge, they are called anion. If there is positive charge, we call them as cation. So out of this, negative charge is on chlorine and positive charge is on sodium. So here the negative charge one is called anion. So chlorine is anion and sodium is cation. And cation and anion will combine together to form compound. Its constituent particles are positively charged sodium ion and negatively charged chlorine ion. So how the sodium chloride is formed? Sodium chloride is combination of Na plus and Cl minus. So here they are getting combined to form sodium chloride, which is compound and it is a charged entity. Now writing a chemical formula. So this is the most important part of your chapter. You need to learn this table thoroughly. And I advise everyone to revise this chapter every day at least 5 times for a week or for 10 days. Then only you can remember this table. And without this table, you are going to suffer in your 10th standard also, where you will not be able to remember the chemical formulas. Chemical reactions cannot be written. If you are unable to remember the chemical reactions, first chapter will become very weak. So here, sodium, it is represented by Na plus, potassium by K plus, silver by Ag plus. So like that you can remember. Out of these, some are monoatomic and these polyatomic ions are very important. This they ask for the definition also, what are polyatomic ions? And the second one, give example of polyatomic ion, where you need to learn out this last column. So here, this is what our first part was. In my first part of explanation of this structure of atom, I covered with few topics, and now we almost reached about the chemical formulas. After that, a few more topics are there. Ultimately, by tomorrow, we'll complete out this chapter where we are going to learn about this crisscross model. This is also very simple. And after covering out this crisscross model, we'll discuss out with the exercise part. So in that way, we are going to complete out. So before winding up the class, let's complete this in-text question. Calculate the molecular mass. So already now every one of you are familiar with how to write the molar masses. So once we'll calculate these masses. So here we need to find out the mass of hydrogen. From the table, you did it. Hydrogen is 1. So first we are going to write this number and then molar mass of hydrogen. Thus it is 2U. For writing oxygen, again 2 are there and oxygen's mass is 16. So it is 32. For chlorine, again 2. Molar mass is 35.5. So it is 71. Don't forget to put U at the last. Now for the carbon dioxide, C is 14, 2 for oxygen, thus it is 14 plus 32. So it's a, okay, this was a mistake I was making in the previous session also. Carbon's atomic mass is 12. So 12 plus 32, it's 44. If we calculate the composition, like how the ratio is given, carbon is 12, oxygen is 32. Now cancel out them. 2 6 are, 2 16s are. So it's 3:8. Now the next one, methane, CH4, carbon is 12, 4, hydrogen, hydrogen is 1. So it's 12 plus 4, 16. So rest all are very simple. You can go through with this exercise. So once you solve this, to understand like whether you understood this topic properly or not. In tomorrow's class, we'll continue with further where we can complete out the remaining one. So here, few more topics are there. Only the crisscross model is there and to find the molar mass. So this is how we calculated. So I think like all of you understood this calculation of the molar mass. Only the last example, 2 more examples are there. Let's cover it. C2H4. Now here 2 carbon are there. So 2 carbon is 12, 4 hydrogen is 1. So it's 24 plus 4, 28U. Now one more example, NH3, nitrogen is 14, 3 hydrogen is 1. So it's 14 plus 3, 17U. Okay, hope like you understood. Thank you for watching constantly. Let's continue with further in part 3. For more such videos, please like and subscribe my channel.